God, I'm here now. um, Hi, everyone. Super excited to be back at Pragma. Thank you for the introduction. And yeah, thank you all for being here after lunch. I hope I can say enough nonsense to wake you up if you're feeling the abbiocco, which is a beautiful word that only exists in Italian. And it's like that post-lunch, like, oh my God, I'm so stuffed, I'm going to fall asleep. So that's vocabulary of the day. Yeah, welcome to my talk called Getting Sentimental, an Exploration of Sentiment Analysis in iOS. I'm Anna. I am from Italy, from a town called Trento, and now I have to prove to someone that I am actually Italian. 33 trentini entrarono a Trento, tutti e 33 trotterellando. I got told I sounded too British, and I say, in what world is that? So, anyways, yeah, that's the rumors quelled. I'm not from Sheffield, but I do live in the UK. I've been in England now for 11 years, and I am a software engineer working at Spotify in the area of developer experience and mobile infrastructure. And yeah, I spoke here last year. It was great. Who was here last year, by the way? Nice. Welcome back. Sometimes I just cringe stuff comes up and I accidentally say it, but I'll try not to do that. Like it just takes over. And also, I'm going to try not to get into like a giggle fit with snort laughs, but I honestly can't make any promises. And no, but like, I'm here for a serious purpose. My goal today is to talk about natural language processing, especially sentiment analysis. Something that is absolutely omnipresent in our current world of LLM and generative AI. But as pervasive and omnipresent as it is, I personally felt there's still a lot of generalized confusion about it. So yeah, I hope that I can explain some things that at least confused me and help you feel a bit more ready to explore some of this stuff. And I'm going to do that through taking you through my chaotic process of building an NLP-based app with varying degrees of success. And we're going to look at some of the solutions that I tried to... I forgot to press the timer to go. Oops. That was 3 bonus minutes for me. Anyways, I'm going to... Sorry. I was trying to resist so hard. Yeah, anyways, yeah, the app is chaotic, just like my talk. I added a lot of resources at the end for you to look at in your own time. Let's actually get started now. So, I work at a large corporation, so I have to happily oblige in all sorts of corporate shenanigans, like performance reviews and feedback cycles and so on. And weirdly, like I enjoy that because I'm a professional overthinker, so that's excellent because with this, I always know what I'm doing wrong and what I'm doing right, and feedback is a very useful tool for that. But what I did is I built like the very bare bones basic app, which is what you see here. Everything is, what do you say? What's it called? Redacted. And I just put it there because I wanted to have a place where I could have just a collection of all the feedback that I received. But then, oh yeah, by the way, this is a very bad app. I wrote it in like a couple hours, Swift data, Swift UI, there's like no test. Oops. And yeah, it's like if you see any code and you go like, oh my God, that's because it was only meant for me and for messing around. So just a disclaimer. But yeah, as I built this and I had the bare bones version of it working, I started to realize that I needed to do a little bit more than just look at the feedback, because what does that do? That doesn't help you. And I wanted to track how I was doing overall over time. That was my idea. And I'm already out of breath. My initial plan was to manually label and assign each feedback as positive, negative, or neutral. But then I realized that language is complicated. Like, it's complicated enough for English speakers, let alone like me. English is not my first language, because English especially as a language, the subtleties of it can be super confusing. Like, I told this story one more time, but a few years ago, I was in a job interview, and the British interviewer asked me a question, and I answered with what I thought was a pretty sensible answer, or so I thought, because he listens to me attentively, and then at the end he's like, interesting. And now I've been in Britain for 11 years, so I know that in British English, that meant that I was absolutely cooked, because it's interesting is not a compliment in British English. So, yeah, language is complicated. And because of that, I needed some help to decode what the British mean with their performance reviews. And I was like, if my app could do this for me in a bit of an empirical way, oh, the natural language framework, it's you. And this kind of like forgotten framework, the NL framework, has been around for a long time. And it's brilliant. It's native. You can just import it. And then for free, you can use a lot of NLP capabilities. But let's take a little step back, not physically. Let's take a metaphorical step back. What is NLP? As I said many times already, language is complicated. Oh, the photo, wait. Sorry. Language is complicated. It's complicated enough for humans, let alone for computers that don't understand anything. For humans to interact with computers, we need something to help make sense, like to help make language, our language, less complicated and less ambiguous. And that is why we have this entire discipline of AI, which is NLP, natural language processing. And it's focused on enabling computers to interpret and respond to human language in a way that is both meaningful and useful. And yeah, that's how machines can make use of written or spoken text through NLP. And how does it do that on a highest level? As a core, we can have something like an NLP pipeline, which is a process made up of a sequence of stages that are necessary to perform an NLP task. And what do I mean with task? Something like translating text, analyzing sentiment, or extracting information and summarizing. So these are all what we can think of as NLP tasks. And the stages that are usually used to perform these tasks are, first of all, tokenization, which is, you're probably familiar with it, breaking down a text into either words or characters, but we're making it into smaller parts. Then we can do stemming or lemmatization, which is basically reducing the words to the root form, like running becomes run, and snort laughing becomes snort laugh? Something like that. I'm not a computer, I'm not doing this. Then we have part-of-speech tagging, which is determining the grammatical role of each token, whether if it's a noun, a verb, an adjective, you get it. And then we can go one step above with named entity recognition. So the noun tokens, we can tell if they're the name of a place, an organization, a person. But these things don't always happen in this order, and they might not even happen all at all, really, because NLP pipelines are very different from each other. And one thing to know is that they are not linear, because each stage can have dynamic connections, it can branch out, they're primed for iteration, you can have feedback cycles. So bottom line is, these are very customizable process. And just like everything that is very customizable, like, do you folks remember there's a show called like Pimp My Ride? Yeah, it's amazing, amazing. I love that show. Well, you can kind of do that. Well, not you, but like machine learning researchers can do that to an NLP pipeline by adding like extra layers called inputs, and that make them more powerful and more effective in performing certain tasks. And that's why we have basically that. One of these inputs is called embeddings. So embeddings are dense, low-dimensional vectors that represent words, phrases, or even entire sentences in a continuous vector space. They capture semantic relationships between words. Please, audio. Oh, no. The audio only worked in my machine. The cat is confused. I was confused. So embeddings are a layer, so a type of input, and they represent tokens as vectors in a multidimensional space, such as the one that I badly tried to draw here. I didn't even make the lines straight or perpendicular, but you get the idea, basically. And a vector can be thought of as a set of multidimensional coordinates. Each coordinate in the vector corresponds to a dimension in the space, and the vector is a point in space. And just a few seconds ago, I robotically described embeddings as dense and low-dimensional. In a dense vector, most or all of the components have non-zero values. And as a low-dimensional vector, which is the most important bit in my opinion, is the fact that the vector has relatively few dimensions compared to the entire possible size of the vocabulary or feature set that it's supposed to represent. And this is because with this low dimensionality, then we can actually make it computationally feasible to process large amount of text data. Otherwise, it would just take too long. And we still do this at a pretty accurate stage. So in this diagram, as I was saying, the word cat might exist like something somewhere above there with those coordinates, and the word feline is pretty close, so might be there. The word menace, that you might understand if you have a cat, is like not too far, but still like not close enough to the cat. So this is just like as an example of how this works. So the natural language framework that is provided by Apple is powered by all of this in varying degrees of intensity, and it also does work in mysterious ways. You'll see in a minute. But let's have like a look at a few things that this framework can do for us. So let's take, by the way, my examples in this talk are absolutely unhinged. I don't know what came over me, so please just indulge me. I didn't have any bar fights with anyone, just to clarify this publicly, okay? I am DBS checked. So the sentence, my friend had a bar fight, if we wanted to tokenize it using the NL tokenizer by the natural language framework class, we'd get my friend had a bar fight. Straightforward. But if we have a little bit more of a problematic sentence, such as that, it might be a bit more difficult. So, oh no, wait, the slide before. Sorry, I have to click it. No, okay, it's good. So don't pay too much attention to the code because it doesn't really matter and you can just read it later. But all you have to know about that is it's not much at all. Like, it's just a few lines. Most of mine are actually comments. But that's all it takes to basically tokenize a string in Swift. And yeah, there are problematic sentence that we just had. O'Neill had a tete-a-tete at Bert and Elmo's bar. It tokenizes it pretty much like we imagine, except for there's something missing, which is the ampersand here, that little symbol. By the way, I just discovered it's called an ampersand, like embarrassingly recently. I just thought it was called the and symbol. That's not the name of it. So just a fun fact. But I was a bit weirded out because I said, why is it ignored? Does NLP in iOS just completely ignore all punctuation? That seems a bit weird if you want to analyze, the meaning of a sentence. That's pretty important. But it turns out that it doesn't. And we know this because if we go through another class, which is called the NL tagger, we can perform parts of speech tagging. So taking each token and understanding if it's a verb, a noun, a punctuation, or more. So the sentence that we have before, my friend had a bar fight, it would basically say that friend, bar, and fight are nouns, and then had is a verb. So that's, as I said, pretty straightforward. And with our problematic sentence, once again, you can see there's not much code at all, like few lines. And the tokenization, the part of speech tagging is pretty effective. O'Neill, it determined it's a noun. That's great because, it could have been, I made it purposefully confusing. Fight, it's a noun. The ampersand is punctuation, so that's pretty straightforward. But you might have noticed that I have been a little bit cheeky here, and I've actually used a different sentence from what I was going to use. I've said fight instead of tête-à-tête. That is because if I used tête-à-tête, for some reason, right, and I actually have no idea the precise reason of why this is working, but the POS is absolutely cooked, and for some reason, everything becomes other word just by introducing a bit of French. And like, I don't really know why this happens. Like, maybe just like Italians, natural language has a bit of a problem with the French. I'm joking. Give us back the Gioconda. I'm joking. Maybe, considering current events, maybe keep it. Please keep the Gioconda. If you read the newspapers, you know why. Anyways, so multi-language text is actually one of the hardest problems in NLP to solve, and it has been up until now. But this problem has a solution, more on that in a second. But I just was amused the fact that I encountered such a problem so soon. Now, in this example, we finally see how natural language handles sentiment scoring, which is what I was interested in from the start for my feedback app. And if you put a piece of string, once again, you see even less code than before. And for the text that you input, the score is going to be minus 1.0 for something super negative, and go all the way up to 1.0 for something positive. Like my example sentence here, O'Neill had a fight at Bert and Elmo's bar. That is horrible. What a terrible example for us all is, rightfully so, minus 1.1. Polarity, if we changed it to be positive, like O'Neill had a fight at the bar, that is hilarious, what an absolute legend. That changes to positive, like we expected. That's amazing. That's easy peasy, right? Now this is the scary part that I'm now extremely regretting, and I'm going to show you how this code behaves in my app. And my hands are shaking. So just so you know, the examples are not real pieces of feedback that I received. Like, this is I all made up for demonstration purposes. OK, so I tried to add the code that I just showed you, like those 3 lines, to what I already had. And it works pretty well with a positive feedback, like, wow, you're awesome, your presentation rocks. I'm so glad I get to see you do this, period. Is 1.0, very positive. Good, this is what we expect. If then we have something that is, ignore the name once again, like, I don't know what I was on, something that is supposed to be very negative, like, I'm not going to sugarcoat it. You suck. You're terrible at your job. You should get fired. Your PRs are hot trash. Fix up soon or face the consequences. That is like, as we expect, yeah, very negative. So I was like, OK, I was pretty satisfied with this so far. And also, just like for curiosity's purpose, I tokenized each, like instead of tokenizing by word, I tokenized by sentence, and I scored each sentence to see if there was anything in particular that was like triggering this. But you know, it looked pretty good. OK, now back to the normal. OK, that went. No, wait. Oh, that went OK. OK, so we have our sentiment score. The talk is finished. No, it's not finished. It looks pretty accurate, but that is not quite sentiment analysis, is it? It's just a score of determining polarity. Is sentiment analysis actually more than that? And yes, otherwise, as I said, we would have gone home now. But sentiment analysis is the process of extracting and classifying the sentiment of opinions from text. It's a subfield of NLP, but it is even more multidisciplinary because on top of artificial intelligence and like very in-depth, like this big of a book, in-depth linguistics, I tried to read it, like it did not go well, but this big book. You also have psychology and data science, social sciences. So yeah, as I said, it's an extremely multidisciplinary field, super interesting. What is even more interesting is that it's being run all the time on everything we say, everywhere. Amazon reviews, hotel reviews, tweets, Reddit posts. Everything that is publicly available is being digested somewhere by a sentiment analysis pipeline. And companies use this to understand, our feelings towards them to do things like develop new products. Governments use it to shape policy, like during the pandemic, governments were actively using sentiment analysis. Like, I read this on a paper, like, I didn't make it up. And yeah, it's crazy. It's super pervasive. A little bit creepy, in my opinion, but that is just my opinion. But yeah, usually this doesn't actually happen on mobile. It's mostly like a massive data pipeline somewhere in the data world, traditionally. But you can do it on mobile, because otherwise, as I said, I wouldn't be here. One very fun fact, without naming names or without naming anything in particular, sometimes these sentiment analysis data pipelines that are run on social medias are able to alert companies of global outages even before official reporting tools, just by literally people moaning about it on Twitter. They're like, oh, wait, this is broken. Yeah, I'm not joking. I saw this somewhere. Please cut that out. But how can we describe and analyze an opinion, in theory? First of all, an opinion cannot be objective. It has to be subjective, otherwise it's not an opinion. Saying the coffee shop is open until 7, it's a fact. But saying, unfortunately, the coffee shop is open until 7, that changes the subjectivity completely, because by adding a word, you're expressing the sentiment that you're pissed off that the coffee shop is not open until after 7. Strange. But anyways, that's how it changes the objectivity. But we can break it down even further, because an opinion can be described beyond the polarity by the type of sentiment, if it's rational or if it's emotional, by the intensity, by the prevailing emotion and the overall mood as well. So we can go even deeper. And a sentence such as, the coffee there is pretty bad and I simply hate it, we can analyze this on a high level, the opinion is that the coffee is bad. It's a negative, mildly intense emotional sentiment, and the emotion is hate, and the mood is bad. And here I drew a little coffee sad. Coffee's never, no, I was about to say something that is preposterous. Coffee can be bad. I live in England, I know. There we go. You're making me laugh. So I wanted to show you some a bit problematic things that I actually encountered at this point with my sentiment analysis big brain moment. Let's take a piece of feedback that is labeled as, I titled this encouraging, and it says, you've made noticeable progress in your writing style since your last draft. Keep working on those transitions between paragraphs to ensure blah, blah, blah. For some reason, Basic NL scored this as, Basic NL is the simple code implementation that I showed earlier, minus 0.6. Because you've made noticeable progress for some reason is minus 0.8. That was a bit weird, and it just didn't get the encouraging sentiment behind this feedback piece. So that was weird. Then we have a more unhinged piece of feedback by O'Neill himself, and he invites us to the bar fight. It's let's meet at Bert and Elmo's bar. Let us fight it out like real men. We could call it a tete-a-tete, but it will involve blood and guts. See you there, punk. Now, it said neutral. If I was to receive this message, I don't know if I would be super neutral. I would be a little bit afraid about the threat of violence. But what I suspect is that addition of the French in there really confused the NL, and it just literally, you see how the score is 0.0, it probably just didn't understand anything in here. So that was funny. Another one that was a bit confusing for Basic NL was from, Drunk Cersei Lannister. And it's hey, girly, I think you're très cool, X. And that was a bit, it was a bit controversial for me what I would score this, because it has a slight passive aggressiveness, because the girly is a bit passive aggressive. But overall, I'd say it's pretty positive. I don't know why it scored it as negative. I think the X, which is in British, in Britain, people just use it to add like a little kiss at the end of a sentence. It just didn't get that. So there's that. And the last piece of feedback, brace yourself, because this is it's pure brain rot. I think you have Riz. Your energy is very sigma, and I think you can cook very often. Big W. I also think you can be nicer in meetings. You're a bit bitch. So that, to me, is not very positive. I'm sorry. I know I'm sigma, and I'm cooking, and I've got Riz, or whatever this stupid, like, slang means, because that's just crazy slang. But I think the second sentence very much does not make this positive. So this was another one of the funny results that I observed. And it turns out that, yeah, language is way more complicated than we think, because a challenge of sentiment analysis is keeping up with slang, dealing with multilingual problems, handling sarcasm, handling passive aggressiveness. And it looks like our sentiment score using basic NL is suffering from that. Fortunately, in the last 15 years, there's been significant advances in SA and NLP that address some of these common challenges. And I made here a list of some of the common methods for sentiment analysis, but some are even more advanced, like deep learning, like convolutional neural networks, and et cetera, but the shiny new stuff is where it's at. And at this point, sorry, I don't know why I said that. At this point in my research, I thought, do you know who always understands my sarcasm? Or even if I say, like, rewrite this to be a bit more Slay Queen and less like boardroom realness? It's her. It's ChatGPT. Although I'm actually trying Claude right now, but that's a different thing. But yeah, it needs no introduction. I think we're all familiar with it. But it's good to point out that the way that it understands the absolute nonsense that we feed it most of the time is through some like really fancy NLP. And this is just this shiny new stuff that I was mentioning like a second ago. So ChatGPT uses GPT models, and they stand for Generative Pre-trained Transformer. Generative, it's obvious. Pre-trained, really cool. It means that it uses transfer learning. And transfer learning is really sick because basically it's like a language model which is trained on like a huge amount of data, and then it's like fine-tuned for specific tasks, so it's even more efficient. Love that for her. And the T stands for transformer. Not the ones from Michael Bay movies, but it's a new type of model architecture which was introduced in a 2017 paper called Attention is All You Need. And as soon as this paper comes out, like, everyone was gagged, like, oh my God, because it literally revolutionized NLP and eventually led to the rise of LLMs and generative AI. But what was the big deal on a high level with this paper? Pretty cool, because it was using something that was invented a few years ago and adapted it and like literally modded it to work with something new, like very innovative and really fancy. The pre-existing invention, which is the encoder-decoder architecture, was up until then like used a very efficient way for models to handle tasks that involve like transforming one sequence into another. So there's that. But the first one of the critical innovations of this transformer model was positional encoding. Oh, I'm running out of breath. So since the transformer processes token in parallel rather than one after the other sequentially, in a way, like, because it needs to be more efficient to train, basically, it needs a way of understanding the orders of words, right? Because if you're doing it sequentially, you know the order of tokens, but if you're going to do it in parallel, you need something to remember where the tokens belong in a sentence, and that's why we have positional encoding. But that's not it, because otherwise the paper would have been called Positional Encoding is All You Need, and it's not. Because the real breakthrough comes from the self-attention mechanism. And to kind of explain how that works, I've made an example for you. Anna meekly asked the waiter at the Savoia Regency if she was allowed to take home the rest of the Parmigiano. She was not. So it's a pretty simple sentence, right? But as humans, most of us are humans here, understand that she, we know it's Anna, not the waiter. And in the part she was not, we also understand that she was not allowed to take home the Parmigiano. So also, as Italians, we understand that Parmigiano is the cheese and not a man from Parma. But sorry, that's bad, che brutta questa, that's bad. But, okay, without attention, a traditional NLP model wouldn't understand this. It would struggle to put two and two together and identify the correct references between the words, especially when they're far apart in text. And that's because those models process tokens, as I said, one by one, and they often lose important context the longer the sequence gets. There were some newer innovations like LSTMs that tried to solve this by applying like a hidden state that carried information through the sequence, but they still struggle because they become quite slow, of course, as you can imagine, if they process everything one by one and keep a hidden state. So self-attention, which is the innovation in attention is all you need, improves on this because it allows the model to consider all parts of the input sequence simultaneously, rather than sequentially, which, yeah, it's why it's so much faster and so much better. And, yeah, that's pretty slay. But there's another type of modern model that uses transformer architecture like GPT models do, and it's called BERT, like the Muppet. It's hidden in the corner. BERT stands for bidirectional encoder representation from transformers. But I think they just called it that so they could name it after the Muppet. Because there's a type of model called Elmo as well. It's gotta be, right? Anyways, so they use self-attention to create these contextual and bidirectional embeddings, like what I was talking about a few slides ago, meaning that the meaning of a word can change depending on the words around it, which is pretty cool. And that's another cool thing that's happening now. So both BERT and GPT models leverage these architectural innovations to be the best in class and the state of the art. And I was reading a literature review at this point, and it said that GPT models were described as magnificent at performing sentiment analysis. So as we say in Italian, my ears went up. Maybe we just say that in Trentino. I don't know if we say that everywhere. But anyways, my ears went up, and I thought, oh, perfect. I'm just going to call the OpenAI API in my app. What can go wrong? What can go wrong indeed? So first I'm going to show you something funny, right? I'm going to show you my prompt, right? Which was, give me a sentiment score in the form of a double for the following piece of feedback. Do not add any extra information, just the score. And I thought I was pretty solid with this. So this is my prompt, my great prompt. And let's see how it performs with some of the examples that I showed you earlier. Sorry, my great state management magic here. For the encouragement feedback, instead of being minus 0.6, slightly negative, now it's more accurate. That's more like it. 0.8, very positive. OK, that's good. That's what I meant. That's what I wanted. From this horrible smorgasbord of Gen Z slang, it understands it's neutral rather than very positive, which is, once again, good. That's what we want. Drunk Cersei, OK, yeah, it gets is very positive. Fair enough. And then, OK, finally, we have our, well, this obviously works great because this is the easy bit. But O'Neill's invitation for a street fight, it's minus 2.5. That's illegal. Do you ever get that warning in Xcode, that's illegal? That's what it makes me think of. So that was quite interesting to see. Oops, there we go. Because it made me think that that was not as foolproof as I thought. And it brings up quite a few problems with this approach. First of all, objectively, if you do something like that in your app, someone's going to get all your users' data, and even if you put it in a privacy policy, I think that's maybe a little dodgy, to be, to be diplomatic. Another problem is like it's obviously not cheap because it's not free, and it's even not the most immediate or reliable to price up because how much each query is going to cost you depends on the input that the user puts, and unless you put a limit, you can't really predict that. Obviously, it's also not offline friendly, so if the conference Wi-Fi is not working, you can't know if your colleagues are being passed algo or not, and that's maybe not ideal. And then lastly, which is to me, what is the most warning bit, is the fact that even with a good prompt, the output is not guaranteed to be what you want because you're going to receive the output as text. So I honestly, and now we're laughing at the prompt that I showed earlier because objectively, yeah, I forgot some pretty important information, but I did think that it was pretty solid, all things considering. So at this point I was thinking like, dude, like I wish I could use transformers and BERT embeddings and transfer learning without the OpenAI API and without having to do weird Python stuff on my Mac. And there is a way to do that. I'm going to try and be a bit fast now because I think I'm kind of running a bit low. But you can use the CreateML app, which you find through the developer tools in Xcode. It's not a separate app. And very quickly, I'm going to show you, this is how it works. If you want to train your own model based on your own training data, here I wrote like several pieces of feedback, and I labeled them as very negative to very positive. I didn't do too much because obviously, like, I have a full-time job as well. But if you wanted to train your own model, you create it, you choose your training data, you choose your algorithm. Like here, for example, let's use this. This is not one of the fancy ones. This is one of the older ones, but still. Maximum entropy. And we're going to train it, and it's trained. Like, it's done it now. Like, this is not recorded. Hello, like, it's real. And then you can download it, and you can drag it either in Playgrounds, if you're like me, or in Xcode, if you're sensible. And you can use it very easily. Where did I put it? Oh, no. Where did I put it? Here. Do it properly, please. All you do is you compile the model, and you get the predicted label from it. And then you can use it already, like your own model that you trained on the data that you want to train it on. So it's pretty cool. And let's see how it works. OK, so here for O'Neill, it understands. I mean, I would have said it very negative, but I should have probably started with a more accurate example, really. OK, the clearly positive feedback, it's in line with both ChatGPT and basic NL as very positive, so that's accurate. The extremely negative one, same. This Riz slang thing, it understands it's neutral, so it's accurate with ChatGPT. With encouragement instead, it's more on the neutral side, which is still not like super accurate, but at least it's not negative, so I was happy with that. And Drunk Cersei, yeah, like not perfect, but better than negative. So, all things considered. What did I do? OK, there you go. So, basically, that's pretty cool because it shows that a CreateML model with task-specific training can perform like comparatively, even like trained with not much data at all, because I saw like I only had 60 items. It does pretty good, like compared to ChatGPT, and it does it for free on device. You can train it on your Mac, which is so cool. So, some observation from my experiments is that sentiment scoring from natural language is easy to do, and it's good for simple analysis. Even a maximum entropy model like the one I just showed you, fine-tuned for a specific scenario, can perform, like as well as ChatGPT, well, or comparatively at least, with minimum effort. And that's even without touching on something called MLX Swift, which is not like a cool bike or anything, is like an API for basically the MLX array framework that Apple machine learning teams use, which is, you can use that. It's really cool, and that's the talk for next year. And the last conclusion is that using OpenAI for purposes other than messaging felt, to me at least, like a little bit dodgy, especially considering all the power that we have available like on our devices directly. So, in the future, I would love to run a proper experiment. This photo is one of my latest failed experiments. and is when I thought I could do cinnamon rolls without rice, using yogurt, and yeah, just I used kefir instead. I didn't measure anything. It was a bit of a disaster. When I told Daniel last time, he was like, I'm not disappointed in you for what you've done. I'm disappointed that you didn't measure anything. Have I taught you nothing? And yeah, I was pretty bad. So it was not reproducible at all. And this was the result. Like, I still ate it. Like, it was good. No, it wasn't good, but edible. And even if you might think it's a bad experiment, I will argue that it's not an experiment at all, because this is the Italian in me, like, it's an exploration. Both my sentiment analysis experiment and the cinnamon rolls. And I promise I'm like literally almost done, sorry. So language is complicated and frustrating, because how can these two words that are so similar to each other technically mean something completely different? But both these things are essential to help us go from something that we know to something that we don't know, and vice versa, and create a wonderful cycle of questions and answers and everything. And one does not exclude the other, which is pretty cool. They're both sides of the same coin, both exploration and experimentations. And together they form like a dynamic cycle of learning. But the cycle inherently involves risk. The risk of failing, the risk of doing a lot of work and literally getting nothing in return and coming back empty-handed and just with a picture of cinnamon rolls to show on the screen. But as T.S. Eliot reminds us, of course I had to put this here, only those who risk going too far can possibly know how far one can go. So I interpreted this as only by welcoming this aspect of risk can we go above and beyond what we thought was possible before. If we want to stay in our like little cozy, risk-free comfort zones, like we're never going to establish what us or the technology that we have is capable of doing, because risk is inherent to gain. And that's what I learned in this process, that to take that leap of faith and embrace the process of sometimes chaotic experimentation, yeah, you're going to surprise yourself with just how far you can go. This is the last quote for you. Is Anna physically incapable of giving a talk without adding a quote at the end? That's probably what you're wondering now, and it has a sentiment polarity of 0.3. So now I'm done. Thank you so much for organizing this conference, for letting me yap on stage. Thanks to my team, and thank you for listening. And this is for the, yeah, thanks.
Thank you, Anna.
Thank you.
Oh no.
I'm so sorry. Oh my God.
I'm good. I'm good.
You said you would do that if I did. You said you would do that if I did bad. What does that mean?
No worries. Yeah, thank you very much. We will skip the questions for this one.
Sorry.
I guess everyone has so many questions.
Find me.
Yeah, but next up,
Thank you.
we have our next guy.